Hello friends, so here we are going to learn many new engineering tools in my new channel, and as a first series of lectures or videos to help you guys, I'm starting with the basics of MATLAB, and I am assuming that all of you are beginners in MATLAB, and for those of you who are experts in MATLAB, you can watch my later videos, but to show justice to everybody and to show justice to the beginners also, I need to explain the very basic programming concepts of MATLAB, and then I'll build on those concepts and explain really critical important points. So I guess MATLAB is becoming a popular computing tool among all the engineers, and sometimes it comes handy for high school students as well. So if you're an engineer, be it a chemical engineer or be it a mechanical engineer or electrical engineer or civil engineer or any other streams, you will have to use MATLAB at one or the other point of your career and your future. So it's always good to learn this tool and then approach the problems with a positive mind. So without much of an introduction, let's go to our first lecture, how to start a new MATLAB program. So when I do this programming, I always start with a clear all and close all. What it helps is it will clear all the variables, all the unnecessary variables, all the unnecessary things that are open can be closed by close all. So this is very good when you are doing a fresh program. And today, as I said, I am going to cover the very basics, and the very basics will be covered by plotting a sine wave and discussing about its amplitude, its frequency, its other characteristics, and how can you manipulate this sine wave in its amplitude, in its frequency, or you can add a DC value to this, and how will it look. Also today I'm going to explain some of the plotting exercises. Those are very simple things, but those are very handy things as well. So let's straight away go and mention an amplitude of a sine wave. So the sine wave, almost everybody must be aware of that, and I'm not going to explain much detail about sine wave. So I'm putting the amplitude of the sine wave as 10, and I'm going to put the frequency of sine wave as f0 is equal to 1 kilohertz, 1 E3. E3 is an exponent. So a we have f0. So usually how it goes, a sine 2 pi f0 start t, and t is a span of this signal. So t I'm going to plot from 0 and in intervals of say 1 e minus 5 to say 5 cycles. 5 cycles means 5e minus 3. How it comes? So you can see the frequency f0 as 1 kilohertz, and the time for one complete wave will be 1 by f0 will be 1 millisecond, and when you plot it till 5 milliseconds, you are going to get 5 cycles. And why is this important? Why is the middle parameter important? That's very important. I'll show you different variations, different waveforms that come up when you vary this. So these things are very important. And then now, say I'm defining x is equal to a star goes for the multiplication, and slash goes for division, plus minus everything goes for addition and subtraction respectively. So here a star sine star 2 star pi star f0 star p. And you must have noticed, why am I putting a semicolon after each and every line? If I'm not putting this semicolon, when I'm running this program, whichever line I did not put a semicolon will get printed in the command window. So I don't want any of these things to be printed in my command window, and so I'm putting a semicolon there. And straight away, how can I plot this? The most simple way to plot it is, you should have two arguments. Plot the x-axis is time and the y-axis is x, and just save this and run. I am saving it as lesson 1 because this is my first lesson, so I am saving it as lesson 1. So I am going to run this. So when I run, here goes our first sine wave. You can see a beautiful, nice sine wave with how many cycles? 1, 2, 3, 4 and 5 cycles. If I want to plot just 2 cycles, I'm just doing this. So I'm going to 2 e power minus 3 and I'm just running it, which is going to give me a very simple thing, which is a 2 cycle sine wave. So you can notice that this sine wave is very smooth now, right? Because the sine expression is evaluated at each 1 e power minus 5, like each 10 microsecond it is evaluated, the expression is evaluated and plotted. Say if I'm making it e power minus 4, what's going to happen? It won't be this smooth. It became squarish. It became so. The obvious reason is this, because it just evaluated only at these very discrete locations, and that's why it got squarish. So if I am putting say 5 e power minus 4, it becomes even squarish. So I see that squarish or something. I don't know what's going to happen. So it becomes something else. All on a sudden it becomes something else. So if I'm putting 2 e power minus 4, it again comes back to the approximate shape of a wave, I guess. Approximately. So this is the basic ideology behind putting a very good sampling for this sampling time period for this signal. And here we are again back to our very smooth sine. So it is here. Yeah, we are back. And now, so as you know, the sine can swing from 1 to minus 1, right? So 1 to minus 1. So when I multiply with 10, it goes from 10 to minus 10. And I put the f0 as 1 e power 3. That is, the inverse of that is 1 millisecond, and you can see that from here all the way till here it's 1 millisecond. So if I want to say, just add something onto this. If I just want to lift this up, say if I want to move from say the top point, if I want it to be 15 and the bottom point as minus 5, I just add a 5 to this, right? Very simple. And you can see from here it just got DC shifted. We call it as DC shifting in electrical engineering. And you can see in the earlier graph the starting point was 0, and this graph the starting point is 5. The starting point is 5, and it goes all the way to 15 and it comes back to minus 5, as opposed to as opposed to minus 10 in the previous case. Okay, let's go back to our previous thing, which is this. It's a very simple sine wave. So you understand how can you play with your amplitude. You can shift up, you can shift down. Easy, very easy. So if I want to plot this as one of the 3 graphs that I want to plot, say I want to plot 3 graphs in one particular plot, in one particular figure, and like 3 columns of graphs. So the command that helps you to do that is subplot, and I am saying that I want to have 3 rows, 1 column, and the third argument will be, I'm saying that where am I putting the current plot. I want to plot it as a first graph. So you can just see what's going to happen here. Just give me this, and you can observe you have space to plot such 2 more graphs. So for you to believe me, if I want to plot it as a second graph, it's very simple. So it's very simple. Just put 2. It comes down. These are very straightforward methods, and this will come in handy in cases where you are going to analyze 3 or 4 signals at once. What's happening to your signal after one particular operation? So this helps, isn't it? So as one more example of this, I'm going to show 3, 2, 2. What does this mean? I have a big figure containing 3 rows, 2 columns, and then where am I placing my current graph? So let me just randomly put it as 4. So I know that there can be 6 graphs in that. So I want to know where I want to say that okay, just keep my graph at 4th position. So let us see where it goes. It went there. So it means to say that here first comes, second comes here, third comes here, fourth here, fifth here, and sixth here. That's the way it's going to work. So let's eliminate this. And today I'm going to say one more trick. You can, if you want to stretch the x-axis of this, you can do it in 2 ways. If you don't want the function to be affected, if you want to keep the x as such, say for example if you are putting just 2t or something, you can do that. So, or if you just want this plot to be extended, what you can do is, now you can see the time period is 1 millisecond, right? Let's put 2 star. What's going to happen there? Now the time period became 2. It's just because I manipulated time. It's just that. Okay. So hope you all have enjoyed my video, the first video, and to go forward I need all of your support. So please subscribe my channel, please like my videos, and please share it to all of your friends so that let us all learn together. And I promise that in the coming videos I'll bring many wonderful things that we can do with MATLAB.